All right, guys, here's your 5-6 lesson. So what you need to do is interact with this video, take good notes while we're doing this lesson, while the video is taking place. Pause things if you need to. And then when you are done, you need to show Mr. Combs and then get the worksheet that you have for homework. So we are on 5-6 and we're doing parallel and perpendicular lines. There we are. So vocab to start off with, you have parallel lines. Parallel lines, these are lines in the same plane that never intersect. You've probably heard of these before. You've probably seen them before. Here is what they would look like. Parallel lines. So you've probably seen them, like I said before. However, when they're in a graph, sometimes we're not quite used to seeing them, obviously, in a graph. But if we have our coordinate plane, then parallel lines could look something like these red lines right here. So there are two lines that never touch. Now mine are a little crooked, which is just my mistake, but they should be straight, both going the same direction, and then the idea is that if they continue on, they will actually never end up touching or intersecting. So these are parallel lines. Your next word is perpendicular lines. These are lines that intersect to form right angles. Lines that intersect to form right angles. So perpendicular lines we would have the coordinate plane. Okay, and in this case, we don't really care about how many units there are, how many spaces there are on the graph. But perpendicular lines. Now, one interesting thing is the axes are actually already perpendicular lines. So here's an example of what perpendicular lines might look like when we graph them. Notice right here we have a 90-degree angle. So on each of these, they create a 90-degree angle. So parallel lines never touch. Perpendicular lines, when you draw them, they create 90-degree angles. The third vocab word you have, and the last one, is opposite reciprocals. Opposite reciprocals. These are two numbers whose product is -1. Two numbers, whose product is -1. Now in parentheses here it says the sloped, I should say slopes with an S, the slopes of perpendicular lines are opposite reciprocals. So here, this is a concept that we have seen before, but it's going to be a little bit different. So reciprocals in general, let's say that you have the number 2. No, let's go with 3/4. Let's say you have 3/4. That's really small. 3/4. Okay? The reciprocal of 3/4 would just be flipped, right? So the reciprocal means you just flip the top and the bottom number. Now, in opposite reciprocal, because it's not just a reciprocal, that would mean not only do you flip it, but then if it started as a positive, then when it ends, it would be negative. So opposite reciprocals mean it's flipped and it's negative where it was positive. Or if it started negative, it would now be positive. So you flip it and the sign switches to the opposite sign. Okay, that's opposite reciprocals. So 3/4 becomes -4/3. The number 2, for instance, is 2/1. Let's say it's -2/1. The opposite reciprocal would be flip it to be 1/2, and then instead of -2/1, it would be positive 1/2. So these are opposite reciprocals. Two numbers whose product is 1. So for instance, if I took the 3/4 and I multiplied that by -4/3 from right here, then 3 times 4 is 12. 4 times 3 is 12. And it's a positive times a negative, so it becomes negative. Well, negative 12 over 12, that just reduces to negative 1. So that's why they're opposite reciprocals. That's how you know that they're opposite reciprocals. Flip it, switch the sign, and then it should equal 1 when you multiply them. You don't have to do that. That's just the concept, helping you understand how it works. So take a look back at those if you need to. Otherwise, we're going to move on. So, slope of parallel lines. A couple notes for you here. First of all, non-vertical lines are parallel if they have the same slope and different y-intercepts. Non-vertical lines are parallel if they have the same slope and different y-intercepts. So, here's what that means. Let's say that you have your graph. And let's say that I'm going to make 2, 4, 6, 8, negative 2, negative 4, negative 6. So let's say you have your coordinate plane, okay, just like that. Here's your y and your x-axis. So, two parallel lines. Let's say that one intersects at positive 4, and another one intersects at negative 1. So notice they're parallel lines. So the slope is actually the same. They're both going in the same direction, growing or increasing upward at the same rate. That's our slope. Yet the y-intercept of this top one is 4, while the y-intercept of this bottom one is negative 1. So that's what we mean when we say non-vertical lines are parallel if they have the same slope, so they're parallel, in different y-intercepts. Okay, that's what we're saying there. The next thing you need to know is that vertical lines are parallel if they have different x-intercepts. Vertical lines are parallel if they have different x-intercepts. What that means, what that means is if you have your coordinate plane, then two vertical lines might be at 3 and 5. So these are parallel vertical lines, but notice the y-intercept, or I'm sorry, the x-intercepts would be 3 and 5. So non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines, like what I've just drawn for you, are parallel if they have different x-intercepts. And then lastly, the graphs of y equals 1/2 x plus 1 and y equals 1/2 x minus 2 are lines that have the same slope, which is 1/2, yet different y-intercepts. So they're parallel. So the point here is, if the slope of one, which is 1/2, is the same as the slope of the other equation, but the y-intercepts are different, they're parallel. Same slopes, 1/2, different y-intercepts, these are parallel lines. So let's look at a problem and see how this works. Writing an equation of a parallel line. So listen carefully and read this. A line passes through 12, 5, that's a point, and it's parallel to the graph of y equals 2/3 x minus 1. What equation represents the line in slope-intercept form? So what we need to do is we need to write an equation in the y equals mx plus b form. So this is what we're trying to get to, slope-intercept. Notice that the one that's given to us here is already in slope-intercept form. So what we need to do is we need to write an equation of the line that passes through 12, 5 on the graph and is parallel to this equation. So there are a couple steps. First, identify the slope of the given line. So, step 1, we need to look at y equals 2/3 x minus 1. That's the equation that's given to us. And we need to identify what's the slope. Well, according to y equals mx plus b, 2/3 is the slope. So, 2/3, there's our slope. That's step 1. Step 2, what we need to understand here is since parallel lines have the same slope, then the new line that we're writing an equation for will also have a slope of 2/3. So if you found the slope from the first one, you already have the new slope. Step 2 is write an equation in point-slope form of the line through 12, 5 with the slope of 2/3. Then transform or convert it to a slope-intercept form. So, watch. Step 2. What we're going to do is we now have the slope of 2/3, and then the problem gives us the point 12, 5. So what we're going to start with is we're going to start by writing an equation in point-slope form. That's this. And the reason we're doing that is because here's a point and here's a slope. So we can write it in point-slope form. We know how to do that. It's easy. So we write y minus 5 equals 2/3, that's our slope, times x minus 12. Now we have it in point-slope form. Now what we can do is we can take this and make it look like slope-intercept form. And here's how we do it. You have parentheses here. So we're going to distribute 2/3 to x and -2. So 2/3 times x is 2/3 x. 2/3 times -12, well, over here, if you would like, 2/3 times -12, or -12 over 1. We have 2 times -12, that's -24 over 3, and that reduces to -8. So that's going to be our answer here. 2x minus 8. Then we have this. Y minus 5 equals 2/3 x minus 8. So notice we're almost there. We have mx plus b is here. However, over here we have y minus 5. In slope-intercept form, though, we want to have just y here. So we're going to add 5 to both sides to get rid of this minus 5. And now we have y equals 2/3 x. -8 plus 5 is -3, minus 3. Now we have our answer. Here is the equation of a line in slope-intercept form that is parallel to the problem we were given. The slope is the same, the y-intercept is different. So, what I'd like you to do is, I know this is a lot, but I'd like you to go ahead and give this one a try. So give it a try and then we'll look at it. So step 1 is we need to identify the slope of the given equation. So here's the point. The point is -3, -1. And the equation is y equals 2x plus 3. So step 1 says that we need to identify the slope. The slope is 2. That means that our slope of the new equation will also be 2. So our second step, we need to write it in y minus y1 equals m times x minus x1. So y minus y1 is -1. So this becomes y plus 1. Oops, sorry. Y plus 1 equals, m is 2. That's right here. That's our slope. Times x minus x1 is negative 3. So this is going to be plus 3. Now, distribute the 2. 2x plus 6. Here we are. Then subtract 1. Y equals 2x plus 5. There's our answer. Y equals 2x plus 5. So hopefully you did that well. If not, by all means, scroll back in the video, look through that again, ask a neighbor who may understand it more than you do. All right, moving on. Slope of perpendicular lines. I'm going to throw it all up here. Two non-vertical lines are perpendicular if the product of their slopes is -1, otherwise known as opposite reciprocals. Okay? So we talked about this earlier. The vocab word was opposite reciprocals. A vertical line and a horizontal line are also perpendicular. So the axes, y-axis, x-axis, are also perpendicular. Here's an example of what we're talking about. Here's two equations. We have y equals 1/2 x minus 1, which has a slope of 1/2. And then we have y equals -2x plus 1, which has a slope of -2. So, to help us understand this, I'm just going to write it out. So notice we have two equations. Here is the slope of the first one, 1/2, and then -2 is the slope of the other one. Well, notice if I take the 1/2 and I flip it so that it's 2/1, and then I make it negative instead of positive, I now have the opposite reciprocal, which is the slope of this one. So because 1/2 and -2 are opposite reciprocals, meaning flip the numerator and the denominator and then make it negative instead of positive, or positive instead of negative, since that's the case, these are opposite reciprocals, which means this line is perpendicular to this line on the graph. All right? So let's look at our next problem, and keep this in mind as we move forward. Classifying lines, your next problem. So the question here is, are the graphs 4y equals -5x plus 12 and y equals 4/5 x minus 8 parallel, perpendicular, or neither? Are they parallel, perpendicular, or neither? So what we need to do is this. First, find the slope of each line by writing its equation in slope-intercept form. So I'm just going to write out both equations real quick. So we have 4y equals -5x plus 12, and then we have y equals 4/5 x minus 8. Two equations. Notice that this one is already in slope-intercept form. Y equals mx plus b. Over here, though, this is sort of mx plus b, because we have -5x plus 12. But notice there's a 4y here. So this is actually not in slope-intercept form yet, because there's a 4 being multiplied by the y. So before I can do anything else, I need to get this into slope-intercept form. And then I can compare their slopes. So the way I'm going to do that is, to undo 4 times y, I can divide by 4. However, when I do that, my 4's cancel out, and I'm left with y equals, over here, you have to remember that when you divide this whole piece by 4, you're dividing -5x by 4 and 12 by 4 separately. So -5 divided by 4 is -5/4 x plus 12 divided by 4 is 3. Now it's in slope-intercept form. Now, -5/4, that's the slope of this one. 4/5 is the slope of this one. So we have to ask ourselves, are these parallel, perpendicular, or neither? Well, if we take negative 5/4 and we line it up next to 4/5, notice what's happened. 5, 4, 4, 5. They've switched. The top and the bottom have switched. So that's a reciprocal. But then this was negative and this one's positive, which means these are opposite reciprocals. Therefore, these would be perpendicular lines. Perpendicular lines because their slopes are opposite reciprocals. So step 1 was to find the slope in slope-intercept form. And then step 2 was to compare the slopes of the lines, which we just did. So step 2, you got to make sure both equations are in slope-intercept form. And then you can compare their slopes and decide, are they parallel, perpendicular, or neither. So try these two examples. The first one is these two, and the second one are these two. Try it out, and then we'll look at it. All right, so we have, the first one is y equals 3/4 x plus 7, and the second one is 4x minus 3y equals 9. So notice already, this is already in slope-intercept form, this one is not. So to get this one in slope-intercept form, we need the x on the other side. So let's subtract 4x, and then we're going to have negative 3y equals negative 4x plus 9. Negative 4x plus 9. Now we need to get this y by itself, so we're going to divide both sides by the negative 3. Y equals negative 4 divided by negative 3 would be left as positive 4 over 3x. 9 divided by negative 3 would be negative 3. So now we have slope-intercept form, slope-intercept form. Compare their slopes now. We have 3/4 and 4/3. Notice that 3 and the 4 switch. However, they're both positive. So while they're reciprocals, they're not opposite reciprocals. And they're also not the same slopes. Therefore, this is neither parallel nor perpendicular. Okay, that's the first one. Now, the second one is 6y equals negative x plus 6. And then we have y equals negative 1/6 x plus 6. So this one's already good, this one's not. Divide by 6. Y equals negative 1 divided by 6 is negative 1/6 x. And then 6 divided by 6 is just 1. So now we have y-intercept form, slope-intercept form rather. So we have a negative 1/6 for this one and a negative 1/6 for this one. Those are the same number. Therefore, these are parallel lines. All right? So slope-intercept form, compare their slopes, figure out if they're parallel, perpendicular, or neither. And the last problem. This time, we are writing an equation just like problem 1. However, we don't want a parallel line, but we want a perpendicular line this time. So let's do this. Notice it's multiple choice, so we're going to disregard the multiple choice examples for now, and we're just going to solve the problem. So step 1, our point is 2, 4, and our equation is y equals 1/3 x minus 1. Step 1 is still just find the slope. So the slope is 1/3. Step 2, find the opposite reciprocal of that, because we want a perpendicular line. So the slope of our new line is going to have to be the opposite reciprocal of the slope of our other line. So the opposite reciprocal of 1/3 would be 3/1, and then since it's positive to begin with, the opposite reciprocal would be negative. Step 3, use point-slope form to write an equation and convert it to slope-intercept form. Same step, or same last step as problem 1. So here we go. We want y minus y1 equals m times x minus x1. Y minus y1 is 4 equals, the slope is, notice, it's negative 3 over 1 now. We're not using the same slope as the other one because it needs to be perpendicular, not parallel. Times x minus x1 is 2. Now we have this. And so now we need to convert it to slope-intercept form. So distribute negative 3 over 1 times x. Well, that's just negative 3x. Negative 3 over 1 times negative 2 is positive, or plus 6. So we distributed. Now we need to get this 4 out of here, and this minus 4. So add 4 to both sides. Y equals negative 3x plus 10. There's our answer. So it's very similar to problem 1, but this time we want a perpendicular line, not a parallel line. So try this next one. Rewind if you need to, but try this one, and then we'll look at it. And this one is 1, 8, and y equals 2x plus 1. First step, our slope is 2, or 2 over 1. Second step is the opposite reciprocal of that. Flip it so it's 1 over 2, and then it needs to be negative instead of positive. Step 3, y minus y1 equals m times x minus x1. Plug in our numbers. Y minus 8 equals 2. No, I'm sorry. That should, I'm going to cross that out completely. That's just wrong. Let's retry that. Y minus 8 equals, the slope is negative 1/2 because it's perpendicular, times x minus 1, and now distribute. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times negative 1 is plus 1/2. Add 8 to both sides. Y equals negative 1/2 x. 1/2 plus 8 is 8.5, which we could just write as 8.5. All right, so that's the answer that you got. Hopefully you got it, or I'm sorry, that's the answer you should have gotten. So hopefully you got that. If not, look through it again. Again, work with someone next to you if you are having trouble understanding this. You may also grab a textbook and you can flip to section 5-6, and that will also help you, so you're free to do that as well. Your homework that you need to get from Mr. Combs is the 5-6 worksheet. So get that from Mr. Combs once you've finished this, taken your notes, so that you can start working on this. Again, if you have any questions, ask someone around you that can help you, and we will go over this and review it on Monday. Otherwise, you should be ready for a quiz on Monday. So be ready for that, and we'll see you then.